I will show you how the user story for joining the SCiON network-enabled network as a native SCiON end host looks like, using well-understood technologies, and also by then showing you how a working deployment looks like. But first, let's go a few steps back and have a look at what we're trying to achieve there, what the goal is. So we want to auto-configure end hosts for native SCiON by using hints that we receive from the network. And so use cases include large campus deployments, where users also might travel between different campuses with different SCiON connectivity, large deployments, or home use, where ease of configuration is important. So everywhere where we need efficient bootstrapping of SCiON connectivity for native SCiON applications. But first, let's have a look at alternative approaches, which you all know already, using SCiON IP gateways. So if we don't need native SCiON, then we can connect to the SCiON network using the SCiON IP gateways only. Or, for example, if we only have SCiON savvy users or administrators deploying bespoke applications and manually configuring those, then we can also use something else than a Bootstrapper. But everywhere else, in the general case, where we want an automated way to configure our end hosts in as standard way as possible, we want something like a Bootstrapper to help us with that configuration. So let's have a look at what components we need to achieve that goal. So we need a zero-conf mechanism that gets us the IP and port information of the bootstrapping server. Then we need the bootstrapping server itself, which is a simple file server that gives us the configuration that we need. So the TRC information as well as the topology information. And then we need the Bootstrapper itself, an application that runs on the end host that we are bootstrapping, and that fetches that information from the bootstrapping server, and then configures the SCiON end host stack. So let's have a closer look at how the bootstrapping happens and which zero configuration mechanisms we want to use. So there are different types of mechanisms that we want to use. We want to use DHCP if that's how we are configuring our network, or we can use different DNS-based mechanisms, such as DNS service pointers, DNS napter, or multicast DNS. So let's have a look at the different steps involved in doing this configuration. So we need the Bootstrapper daemon running on the end host that we are bootstrapping, as already mentioned. Then we can either use a DHCP server that gives us this hint, or a DNS server. We are sending out in parallel those requests for those hints. And let's assume, for example, that some of the requests, like the multicast DNS requests, do not succeed because we have, for example, no multicast configured on our network. We're also sending out DHCP requests. And then, as soon as we receive the first reply to those requests, we then start fetching the configuration from the bootstrapping server to get this configuration information. And then we apply this configuration. So we configure our SCiON daemon and the SCiON dispatcher on our host using this TRC and topology file. So as soon as we have done that, we then can start or restart the SCiON dispatcher and the SCiON daemon respectively. Now let's have a closer look at how this looks like in practice. So this is a video demo I will present you. So on the top right side, you see all the SCiON services running on the host that we are bootstrapping. On the bottom left, we are looking at all the configuration files that are present at in the system. And on the bottom right, we are looking at the files at the network capture on the bootstrapping server. And so on the top left, you see that we are installing a Debian package, as you would install any other Debian package. And then on the top right, we see that the Bootstrapper is started, and then also starts the SCiON end host services. And on the bottom left, you see that we now have the required configuration. Now we install some additional package, SCiON tools package from our repository, to just check that indeed the connection is set up as we want and that we have a working SCiON control plane. So that's for the demo. Now, this implementation of this Bootstrapper is open source and is available under the following repository. And I also like to acknowledge Jan Wien, Matt Kowalski, and the other contributors to the repository, as well as the project this Bootstrapper depends on, Insomniac DHCP for the DHCP part, and MixDNS for the DNS requests. Now, thank you for your attention. There's now some time for your questions or some discussion of points listed on this slide or any other topic you would like to cover more in depth. Thank you for your attention.
Thank you, Francois. We have one quick question for you. What do I need to set this up in my own network?
So, as we have seen in the presentation, on the Endos that you're bootstrapping, you only need to install a package as you would install any other package. And on your network, it's enough to have either of those enabled. So probably you already have DHCP, or if you're statically configuring your hosts, you probably have some DNS available. And then you just need to set up those to have the required DNS entries. So either pointer records for your service, or NAPTR records for your service, and then a file server that can statically serve those configuration files that you need to run it.
Thank you. We have another one, if you don't mind. How do you think bootstrapping can help to scale SCiON deployments?
So there's two parts to that. So for scaling SCiON using current IP applications, I think the SCiON IP gateway is a very good product. But if you want to make use of native SCiON applications that can make use of the multipassing feature directly from the application itself, or where you want to have more control from your application, then having a Bootstrapper that can auto-configure for you the end host will help you a lot.
Great. Thank you, Ali and Francois. We're very excited to hear more from you. Thank you so much. By the way, Ali is online answering other questions via our online moderation tool. Thank you, Francois.